Okay, so we're sketching the graph of this parabola. It's just a monic quadratic we've got here. Now we've got to state the x-intercept, the y-intercepts there could be, and the turning point. Okay, so first and probably easiest one to do is the y-intercept when it's written in this form. Okay, so remember y-intercept occurs when x is equal to 0. So it occurs at x equal to 0. So let's put x equal to 0 into that equation. We're going to have y equals 0 getting squared minus 3 lots of 0 minus 10. Well, it's all 0 there, so it's just 0 minus 10, which is negative 10. So it's crossing the y-axis at negative 10. So 0, negative 10 is our y-intercept. Okay, so easy marks on the board just for that first little bit. Next is to work out the x-intercepts. Now that's a little bit more challenging when we've got a quadratic. Okay, so x-intercept occurs at y equal to 0. Okay, so take that equation, put 0 in here for y. Let's write it down here. 0 equals x squared minus 3x minus 10. Okay. And now this is what we've just been doing on solving quadratics. So we've got to try and factorise this little guy and then use the null factor law to work out the x-intercepts. So we're going to go 0 equals, okay, and set it out like this. Because it's monic, we can go straight to having x's there. And then remember, we're looking for two numbers that multiply together to give negative 10. Now you don't always have to write this out, but sometimes it helps. I'm going to rub this out in a second, but I sort of tend to do this in my head now. I go two numbers that multiply together to give negative 10, negative 10 and 1, but that's negative 9 when you add them together. We're aiming to have it to be negative 3. Let's see, negative 5 and positive 2. Well, that gives us negative 3. We can do that. Okay, they multiply together to give negative 10, add together to give negative 3. So that's the combination we want, minus 5 plus 2. And therefore, so that means that our null factor law, remember, is saying that x is going to be equal to, change the sign on that, 5, or x is equal to negative 2. So our x-intercepts are 5, 0, and negative 2, 0. Remember, it's x there and y there. So we've worked out x values when y is equal to 0. Okay, so we can start sort of doing our rough sketch over here, and we've got a fair bit of the information. There's still a little bit that we've got left to do. We've got to do the turning point, but hopefully we've got the idea that I'm just going to do a really rough sketch here. Just got to label the features. So I'm going to say negative 10 is, say, down here somewhere. And remember, that's where our parabola is crossing the y-axis, and it's crossing the x-axis over here at positive 5. So 5, positive 0, and negative 2. So I'll just look, I'm just doing arbitrary points, trying to make it look roughly right. Okay. Now the next part is to work out our turning point. So I hope everyone's got the idea that because this parabola has a positive a value, it's going to be concave up. It's going to be a smiley face like that. Okay. But we've just got to work out. So we're going to have it coming down here, crossing there, going all the way down and crossing there, and at some stage here, we're going to have a turning point. It's going to be halfway because a parabola has symmetry about the turning point. The turning point is going to be halfway in between the two roots, or the two x-intercepts here. So I'm going to find where that point is, halfway in between those two. So the turning point is equal to, we've got negative 2 plus 5 over 2, halfway in between the two. Okay, so halfway in between that is 1.5, or 3 on 2. So 1.5 is our x value. So, sorry, I should be saying in here, this is the x value of that is going to occur at 1.5. Now, the other way of getting the turning point for the x is to say that it is at negative b over 2a. Now, remember, negative b is negative 3 over 2a, 2 times a is 1, so that's going to be a positive 3 over 2, or 1.5, same deal. So at 1.5, so again, it's around about there. Okay, around about what we said. So 1.5 is your x value. It's going to be occurring along here. So I'm just putting in our axis of symmetry, which is at x equals 1.5 or 3 on 2. And we've just got to work out now, though, what the y value is going to be here of our turning point. So we know it's going to be 1.5 and then something. So to work out that value, we've got to say at x equal to 1.5 or 3 on 2, probably best to put it in as an improper fraction. Y is going to be equal to 3 on 2 getting squared minus 3 lots of 3 on 2 minus 10. Now, let's work out what that is now. If we're doing a tech-free exam, you would be trying to do this without a calculator. 9 on 4, square them both, minus 9 on 2 minus 10. Okay, now it's a little bit nasty here in a way, so we'd have to make it so that they've all got a common denominator. Yeah, let's just do it. So I can make this have a denominator of 4 by doing that. Make that have a denominator of 4 as well. 9 minus 18 is negative 9. Negative 9 minus another 40 is negative 49 over 4. Now that works out to be, we've got 12, negative 12 and a quarter. So that's going all the way down here to negative 12 and a quarter. If I've done that right, which possibly haven't. Where did I go wrong? Did I go wrong? Let's just get out the calculator, double check that, because it seems like it's a little bit far down, but it could be right. It's going, what are we going? 3 on 2 is getting squared minus 3 lots of 3 on 2. I left out 3. Minus 10. Let's do S to D. Yeah, getting right. Okay, so that's it then. We've now successfully got the turning point. We've got the y-intercept, so that's our y-intercept there. These are our x-intercepts, there, and that's our turning point. Okay, and that's the sketch of y equals x squared minus 3x minus 10. So there are more to do from exercise 9.3 if you wanted to follow up on that.